solve the above question. Says the diagram below shows the cross-section area of a cast iron beam. When this beam is subjected to a bending moment, the tensile stress at the bottom edge is 30 meganewton per meter square. So we want to calculate the value of the bending moment and the stress induced at the top edge. All right, so you can see the diagram clearly. Now, you can see the total length here is 30 centimeter. From this point to this point is 4 cm. From this point to this point is 15 cm. While the width here is 2 cm. And from this point to this point, that is from this point to this point, is 2 cm as well. Similarly with this, y from here to here is 12 cm. All right, so we are going to start by calculating the position of the neutral axis. And for us to do that, we are going to divide this section into 5 rectangles. So here we are going to right. All right, so this is 1, this is 2, this is 3, this is 4, and this is 5. All right, so for us to calculate the position of the neutral axis, we are going to be using this formula. So we are saying A1 Y1 plus A2 Y2 plus A3 Y3 plus A4 Y4 plus A5 Y5. So divided by the total area, which is A1 plus A2 plus A3 plus A4 plus A5. All right. So the next thing we are going to do now is to calculate the area of the first rectangle. You are going to agree with me that the first rectangle and the second rectangle, they are same because they are having the same length and breadth. Similarly with rectangle 3 and 4. So that makes our work very easy. All right. So now area for the first rectangle now will be equals to, is going to be equals to, now from this point to this point is going to be what? Now the total length here is 30. 30 minus 12, that is 18, right? So if we divide 18 by 2, we are going to have 9. So it shows that from this point to this point is going to be 9. From this point to this point is going to be 9. So by the time you say 9 plus from this point to this point, which is 12 plus 9, you are going to get 30. So it shows that this point to this point is 9. This point to this point is also 9. All right. So here we are going to have 2 multiplied by 9, which is what? 18 cm squared. All right. So it means that our A2 will also be equals to 18 cm squared. All right. So let's go for A3 now. A3 will be equals to 15 multiplied by what? The width is what? 2. So it's going to be 18 multiplied by 2. And 18 multiplied by 2 is what? Is 36. It's 36. So we're going to have 36 cm squared. All right. So A3 will be the same thing as A4. So A4 will be equals to 36 cm squared. All right. So let's go for A5 now. A5 will be equals to, now A5 is going to be equals to, this is the rectangle here. The total that's going to be 12 plus 2 plus 2. That is 14, 16. That is 16. And the width is what? That is 2. That is 16 multiplied by 2. So 16 multiplied by 2 is going to be equals to 16 multiplied by 2 is going to give us what? 32 cm squared. So we are done with the calculation of all the areas. All right. So now the next thing we are going to calculate is our y1, y2, that is the neutral axis of our y1 from the bottom face and the 2 and 3. So similarly, if a1 is equals to a2, shows that y1 will also be equals to y2, y3 will be equals to y4. So let's start with y1. So y1 will be equals to, so from the bottom to the neutral axis. Now let's move on. So now this is our rectangle here. So the width is 4. So it's going to be 4 divided by 2, which is going to give us what? 2 cm. So similarly, our y2 will be equals to 2 cm. All right. So y3 now. y3 will be equals to, now this is our third rectangle, and we are moving from the bottom. So it's going to be the first rectangle, which is 4 here. It's going to be 4 cm plus what? Plus 15 divided by 2. So 4 plus 15 divided by 2 is going to give us nothing but what? 11.5 cm. So similarly, our y4 will be equals to 11.5 cm. All right. So now let's go for y5. y5 will be equals to, so the fifth rectangle now is going to be equals to, so we are moving 4 plus 15, then plus 2 divided by 2. So it's going to be 4 plus 15 plus 2 divided by 2. So this will be equals to, this is 19 plus 1. That is what? 20. So we are going to have 20 cm. All right. So we are done with y1 and y2. So now let's substitute here. So we are going to have our y bar to be equals to a1. Our a1 is 18. So 18 multiplied by y1. y1 is 2 plus a2. a2 is 18 as well. Multiplied by y2. y2 is 2 as well. Plus a3. a3 is 36. So it's going to be 36 multiplied by y3. y3 is 11.5. Plus a4. a4 is 36. 36 multiplied by y4. y4 is 11.5. Plus a5. a5 is 32. 32 multiplied by y5, that is 20. All right. So everything divided by a1, a2. a1 is 18. a2 is 18. a3 is 36. And a4 is 36. And a5 is 20. All right. So by the time you press 18 times 2 plus 18 times 2 and you press this, you are going to have this to be equals to, so we are going to have this to be 1474. So divided by, if you sum everything that we have here, you are going to have 164 as well. All right, so this will be equals to, if you divide 164 by 1404, we are going to have 8.90. So, and if you approximate, you are going to have, if you approximate this, you are going to have this to be 9 cm. So we are going to be using 9 cm here for the neutral axis. So shows that from the bottom part to the neutral axis is going to be what? 9 cm. So and what is the whole length here? The whole length here is 4 15, that is 19, 20, 21 is 21. So it shows that 9 cm from the bottom here is going to be somewhere around here. If you draw the neutral axis, so it's going to be from the bottom to the neutral is going to be 9. So it's going to be somewhere around here. So, and don't forget, the bottom part is our tension part. So it shows that the y bar here is going to be the same thing as our yt. So which is going to be what? 9 cm. And our y subscript c now is going to be 21 minus 9. And 21 minus 9 is nothing but what? 12. So it's going to be 12 cm. All right. So now, the next thing we are going to work on now is the moment of inertia. So moment of inertia for each of the rectangles about the neutral axis. So here, this is going to be I, because we have 5 rectangles there. It's going to be I1 plus I2 plus I3 plus I4 plus I5. All right. So I1. So don't forget. Now, I will not waste our time here. I1 and I2, they'll be the same thing, right? So let's just sum them together. So let's just say I1 to I2, or let's just say I1 plus I2 here. So this will be equals to 2 into BD cubed all over 12 plus, is either you use A1 or A2. You can see A1 is the same thing as A2. So into, then you check your Y bar and Y1, which one is greater? Our Y1 is 2, our Y, so it's going to be Y bar minus Y1 all squared. So you close your bracket. So this will be equals to 2 into our base. So the base and the depth. This is the depth. The base is going to be 9. So 9 times 4. 9 times 4 cubed all over 12 plus A1. What is our A1? Our A1 is 18 into our Y bar. Our Y bar is 9 minus Y1, which is 2, all squared. So you close. So our answer here, if we do this, we are going to have this to be 3,624 centimeter to the power of 4. All right, so that is what we are going to have. So similarly for our I3 and 4, so let's just sum them together. 3 plus 4. So this will be equals to 2 into BD cubed all over 12 plus, you can use A3 or A4. They are the same thing, into, now let's check between Y bar and A3, which one is greater? You can see Y3 is greater than Y bar. So we are going to use Y3 minus Y bar. We are trying to neglect the negative sign. So that is just the trick behind the formula. So this will be equals to, if you substitute now, we're going to have 2 into the base and the depth. The depth is 15. The base is 2. So it's going to be 2 multiplied by 15 cubed all over 12 plus A3. What is A3? A3 is nothing but what? 36. So it's going to be 36 into Y3. Our Y3 is nothing but what? 11.5 minus Y bar. What is Y bar? That is 9. All squared. So you close. So again, if you press this directly in your calculator, you are going to have this to be 1,500 centimeter to the power of 4. All right. So the last but not the least is I5. So this is going to be BD cubed all over 12 plus A5 into, so now let's check between Y bar and our Y5. So our Y5 is greater. It's going to be Y5 minus Y bar all squared. So if you substitute now, we are going to have this to be equals to the base and the width. The width, the depth is 2, while the base is going to be 16. So it's going to be 16 times 2 to the power of 3 divided by 12 plus our A5. Our A5 is 32. So we are going to have 32 into Y5. What is Y5? Y5 is 20. So it's going to be 20 minus 9 all squared. All right. So the summation of this answer is going to give us, all right, I'm coming. All right. So the summation of this I5. All right. So if you press this, you are going to have this to be nothing but 3,883. 3,883. 3 centimeter to the power of 4. All right. So now if we sum everything together now, our I will be equals to I1. I1 plus I2 is nothing but what? 3,624. 3,624 plus, if you sum I3 plus I4 together, I'm going to have this to be 1,500. 1,500. All right. So, and our I5 is going to be 3,883. All right. So now, if we sum everything together, you are going to have 9,007. Sorry for the little. 9,007 centimeter to the power of 4. All right. So for clarity, I'm going to clean. We can therefore take this to be in a meter. All right. So for us to, if you have if you want to take from centimeter to meter, we divide by 100, right? But because it is into power 4, we just put to power 4. So then we can therefore say this is equals to 9,007 times 10 to the power of minus 8. So this is going to be meter to the power of 4. So this is what we are going to have. All right. So we are done with the moment of inertia of this section now. Now let's start with the for solution to the question number 1. So for question number 1, we are told to find the bending moment. So we are going to be applying the Fleischer equation. So our maximum bending moment all over our moment of inertia is equals to our stress all over what our y max. All right. So, but if you look at this question, we have already been given our bending, our tensile stress at the bottom edge is 30 meganewton per watt per meter. Don't forget tensile. So if it is tensile, it means this one too, this is tensile, this one too is going to be what? Tensile, right? All right. So let's make our maximum bending moment the subject. So this is going to be equals to the tensile stress, maximum tensile stress, all over what? Y tensile multiplied by what? By I. So the maximum bending moment now, if we substitute now, we are going to have this 30. So it's going to be 30 multiplied by, because it is mega, it's going to be 10 to the power of 6. Then times what? Our I. Our I is 9,007 times 10 to the power of minus 8. Then divided by what? Divided by Y subscriptive, which is what? 9. So 9, but don't forget it is in centimeters, so we divide by 100. So it's going to be 10 to the power of minus 2. All right. So if we do that, our maximum bending moment will be equals to, if you press this and you divide by this, you are going to have 3,023. So our answer is going to be in Newton meter. So in Newton meter. So that is going to be our answer. And if you divide by 1,000, you can also write your answer as 30.023, which you can write as 30 kilonewton meter. All right, so that's it. So for question number 2, we are asked to find the stress induced at the top edge. So the stress induced at the top edge is what? Is our what? Compressive stress. All right. So if it is compressive, it shows that we can no longer use Y tensile. We are going to be using Y compressive. So we'll still be using this same formula, but we are going to be, okay, let me just rewrite it again. M all over I will be equals to this compressive, then this one too is going to be compressive. So this is what we want to look for. To make it the subject, I'm going to have M over I, then multiply by what? Y compressive. So if we substitute now, we are going to have this to be equals to our moment, maximum bending moment, which is 3,023 23, then multiplied by y compressive. Y compressive is 12 centimeters. So if you take it to meter, it's going to be multiplied by 10 to the power of 2, then divided by our moment of inertia, which is 9007 times 10 to the power of -8. So this will be equals to, so if you press this, you are going to have your answer to be nothing but 40 times 10. This is going to be 40 times 10 to the power of 6, which is going to be Newton. The unit is going to be Newton per what? Per meter squared. So which you can replace this 10 to the power of 6 with what? Mega. So your answer is going to be 40 mega Newton per meter squared. So this is how to solve this amazing question. I believe you understand this. Stay tuned for more interesting content. And if this is your first time of coming across our video, please don't forget to give this video a thumbs up, subscribe, and stay tuned for more interesting content. And don't forget to also share with your friends who might be in need of this. Thanks.